Hey everyone, this is number 3 of the 2018 FRQ exam, and this is the no calculator section. So this is number 3, part A. It says the graph of the continuous function g, the derivative of the function f, is shown above. So the continuous function g is the derivative of f. I'm going to put a label on my graph. If you want to try and think about what that label is going to be based on what I highlighted in red. And I'm going to write that g is equal to f prime. They told me that the function g is the derivative of f, so g is f prime. The function g is piecewise linear from -5 to 3, and then g of x is equal to 2 times x minus 4 squared for 3 to 6. So piecewise linear means that this is a piecewise function, and it's made up of line segments, right? Linear. And then once you get to x equals 3, from 3 to 6, the function is parabolic, and it gives you the formula for that parabola. All right, so the first question, part A, says f of 1 is equal to 3. What is the value of f of -5? So the first question that I have for you is, if you are looking at a graph of f prime and you're being asked about f, my question is, how do you get from f prime to f? And the way you would do that from f prime to f is by taking the antiderivative. The antiderivative of f prime is f, and the derivative of f is f prime. So we are going to be using the antiderivative in some way to get from f prime back to f. And I think I'm going to stick with what we've been doing all year, which is the initial plus change formula. The initial is f of 1. So I'm going to write f of -5. That's what they're trying to get us to figure out, f of -5. My initial is f of 1, and then plus my change. So I'm going to do the antiderivative of f prime, because that's going to bring me back to the f function. And then think about what that upper limit and the lower limit should be. This is a little bit strange here. So the lower limit is 1 and the upper limit is -5. So this is going to be the formula that we're going to work from. And I'm going to just, in parentheses, tell you why this makes sense. This makes sense because we have our f of 1 that I'm bringing down, plus sign. The antiderivative of f prime is f of x. Right? The antiderivative of f prime is f, and you would have your bracket 1 to -5. Bringing down that f of 1, when you plug in the top number and you plug in the bottom number and subtract, looks like this. And then the f of 1s cancel out, and it leaves you with f of -5. So none of that is work that you have to write down, but that is us showing why this the expression on the right side makes sense. It makes sense because you have f of 1 in the front. You have the antiderivative of f prime is the f function. When you plug in the numbers and subtract, the f of 1s cancel, and you're left with f of -5. So this is going to be the formula that we are working with. And let me see if I can do that. Okay. So now we're going to go back to that equation that we wrote and work with the expression on the right side. So f of 1 is equal to 3. That comes from the question that's highlighted in yellow. Then we're actually not going to take this antiderivative right now, because if we go back to the f function, we just don't have that information, right? If we had f of -5 minus f of 1, we don't have an equation to use. We don't have a graph to use that we would be able to evaluate that. So the way that we're going to interpret and evaluate this integral is, remember the two ways that you can evaluate an integral. The two ways you can evaluate an integral are by finding an antiderivative and plugging in the numbers, or by interpreting it and evaluating it using area under the curve. And you can see that from 1 to -5, those are all shapes, geometric shapes that you would be able to find the area of. So we're going to do this. Instead of going 1 to -5, because that would be moving from right to left, it's kind of backwards, it makes the base negative, it's a little bit confusing. I'm going to flip those numbers over. However, if I do that, I need to change this sign. So this plus sign is going to go to minus, and I'm going to flip the numbers over. So I'm going -5 to 1. Then all I need to do is find the area under the f prime curve from -5 to 1 in order to evaluate that definite integral. So I'm going to go back up to my graph, -5 to 1. And this shape right here, you can use a trapezoid, or you can use a square and a triangle. So that's up to you. I will use the trapezoid. So 1/2 the height, B1 and B2. The height is going to be 1, 2, 3. And then our base is here. So that's 1, 2, 3, 4. And the other base is here. That's 1, 2, 3. So I get 1/2 of 3 times 7. 3 times 7 is 21 times 1/2. So 21 over 2 is going to be that area. And I'm going to write it as -21 over 2 because it's below the x-axis. And then we're doing that area all the way to 1. So this is 0 area, that horizontal line segment there. But then we do need this area right here. And that is a triangle. So we're going 1/2, the base is 1, the height is 2. And you get 1. So that area is 1, that'd be a positive 1 because the area is above the x-axis. And remember that we changed our base to go from -5 to 1, so our bases are positive and we have our areas. So we have f of 1 is 3 minus sign. The area from -5 to 1 was -21 over 2 and the positive 1. And I am just thinking, what is the value of f of -5? So I believe that you could be done at this point and leave it unsimplified. So let's just look at the rubric for a second. If you were able to set up the integral and kind of know that you are doing the area under the curve, that was a point, and then you got another point for the answer. I was just looking at how they wrote it as g of x. They didn't write f prime like we wrote f prime right here, but we did define it up here. We said the graph of g is the same as the graph of f prime. So I believe that you would be able to use f prime in your integral, and you don't have to write it as a g, although g would be correct as well because they're equal to each other. If you wanted to finish this, you could distribute the minus sign. So you would get a positive 21 over 2, and you would get a -1. Then, if you were going to keep simplifying, I would probably do the 3 minus 1, 2 plus 21 over 2. Sorry, this is the previous work we had written. Then you would need a common denominator if you were going to keep going. So this is 2 over 1. Your common denominator would be 2. So you would multiply by 2 over 2 and get 4 over 2 plus 21 over 2 is 25 over 2. And that was the answer they listed. But again, I keep pointing this out, and I'm sure you remember this, that you are allowed to leave very unsimplified answers. So you could leave it in that form that I just circled. And I believe that's it. So the point for the integral, the point for the answer, and that is it for this question.